In this video, I'm going to discuss the formula for finding the value of y for any given x. So that is one of the important formula is Newton's backward interpolation formula. Let us derive the Newton's backward interpolation formula. Let x1 x0 comma y0 x1 comma y1 and so on xn comma yn be with n plus 1 tabular points of the function y is equal to f of x, where x are equally spaced such that xi is equal to x0 plus ih, where I is equal to 0, 1, n. Now to construct the interpolating polynomial by using the given data points, that is x0, y0, x1, y1 and so on xn, yn. Let y of x be the nth degree polynomial such that y of x0 is equal to y0, y of x1 is equal to y1 and so on, y of xn is equal to yn, where y0, y1 and so on yn are the points from the given data points. Here y of x0, y of x1 and so on y of xn are obtained from the nth degree polynomial, and moreover, according to the definition of interpolation, y of x0 is same as y0, y of x1 is same as y1 and so on, y of xn is same as yn. Now let us construct the nth degree polynomial. Let y of x is equal to a0 plus a1 into x minus xn plus a2 into x minus xn into x minus xn minus 1 plus and so on an into x minus xn x minus xn minus 1 into and so on x minus x0. So this is equation 1. Here I assumed the nth degree polynomial such that a0, a1, a2 and so on an are the unknowns to be determined by using the data points x0, y0, x1, y1 and so on xn, yn. So now to find a0, you take x is equal to xn in equation 1. So where xn is the end points of the interval x0 xn. So I'm using the values from the end points of the interval x0 and xn. To take x equal to xn in equation 1, we get y of xn is equal to a0 plus 0. When x equal to xn minus x0 xn 0, Similarly, a2 also 0, some other terms also 0 here. So this implies a2 is equal to yn, since y of xn is same as yn. So where yn is the end value of the y from the data points. So y of xn is same as yn, where y of xn is the value of y from the polynomial equation 1. So y of xn is same as yn according to the definition of interpolation. So sorry, this is no, a naught is equal to yn. Now to find the value of a1, we take x is equal to xn minus 1 in equation 1. We get y of xn minus 1 is equal to a naught plus a1 into xn minus 1 minus xn plus a2 into 0. Further, all the terms are zeros. Since y of xn minus 1 is equal to yn minus 1, a naught is equal to yn, and also we know that x is equal to x naught plus ih. So now we have xn minus 1 minus xn can be written as in terms of x naught, that is x naught plus n minus 1 into h minus of x naught plus n into h. X naught minus x naught get cancel. You can observe that here nh minus nh it cancel, so that remaining is minus h. Yeah. So therefore y of xn minus 1 becomes yn minus 1. A naught is nothing but yn plus a1 into xn minus 1 minus xn is nothing but minus h. So this implies a1 is equal to yn minus 1 minus yn divided by minus h. So this implies so n is equal to yn minus 1 by h. So this is equal to yn minus 1 by using backward difference operator, so that can be written as nabla yn divided by h. Therefore a1 an sorry this is a1, this is a1 is equal to yn minus 1 by h. So therefore a1 is equal to nabla yn divided by h, where a naught is equal to yn and a1 is equal to nabla yn by h. So next we take x equal to xn minus 2. Take x is equal to xn minus 2. In equation 1 we get y of xn minus 2 is equal to a naught plus a1 into xn minus 2 minus xn plus a2 into xn minus 2 minus xn into xn minus 2 minus xn minus 1. Yes. So since y of xn minus 2 is equal to yn minus 2. So this is from the definition of interpolation, where a0 is equal to yn and a1 is equal to nabla yn by h. And we know that xi is equal to x naught plus ih. Therefore xn minus 2 minus xn can be written as x naught plus n minus 2 into h minus xn is x naught plus nh. X naught minus x naught get cancel, nh minus nh it cancel, so rest is minus 2 into h. Similarly, you can find out xn minus 2 minus xn minus 1 also. Xn minus 2 is equal to x naught plus n minus 2 into h minus of here xn minus 1 is x naught plus n minus 1 into h. X naught minus x naught get cancel, so this is equal to nh minus 2h minus nh minus into minus plus h here. So nh minus h get cancel, so minus 2h plus h is minus h. So therefore, this equation becomes y of xn minus 2 is equal to y n minus 2 is equal to a naught is yn plus a1 is nabla yn by h into xn minus 2 minus xn is here minus 2h plus a2 into xn minus 2 minus xn is minus 2h into xn minus 2 minus xn minus n is minus h into minus h. So this implies yn minus 2 minus yn goes to LHS, that becomes minus yn, h and h get cancel, that is minus 2 times of nabla yn goes to that LHS, that becomes plus 2 nabla yn is equal to a2 into h minus into minus plus h into h square, that is 2 h square. So this implies a2 is equal to yn minus 2 minus yn plus 2 times of nabla yn, nothing but yn minus yn minus 1 by using backward differences by 2 times of h square. So this implies yn minus 2 minus yn plus 2 yn minus 2 yn minus 1 by 2 h square. This is equal to 2 yn minus yn, nothing but yn minus 2 times of yn minus 1 plus yn minus 2 by 2 h square. So this is equal to, so by using the second backward difference for yn can be written as nabla square yn, by using 2 can be written as 2 factorial into h square. Therefore, E2 is equal to nabla square yn by 2 factorial into h square. Similarly, we can write A3 on the base of A2. So A3 is equal to nabla cube yn by 3 factorial into h cube and so on. Therefore, n can be written as nabla n yn by n factorial into h power n. Now substituting a0, a1, a2 and so on an in equation 1, we get y of x is equal to y a1 a0 is yn plus x minus xn into a1 is nabla yn plus x minus xn into x minus xn minus 1 into a2 is nabla square yn by 2 factorial into h square and so on plus x minus xn x minus xn minus 1 and so on x minus x naught into n is nabla n yn by n factorial into h power n. Here x is arbitrary, any value within the interval x naught xn or outside the interval x naught xn. So setting x is equal to xn plus ph, where xn is the end value of the values of x here, where p is a real number. So this implies x minus xn is equal to ph. Similarly, we can write x minus xn minus 1. So that is x minus xn minus 1 is where x is xn plus ph minus of where xn minus 1 in terms of xn, that is xn minus h in fact. So xn minus h will get immediately previous value, that is xn minus 1, where xn minus xn get cancelled, that is equal to ph minus into minus plus h. So this can be written as p plus 1 into h. So similarly we can write x minus xn minus 2. So that can be written as, on the basis of previous result, that can be written as p plus 2 into and on x minus x1 is now p plus n minus 1 into h. Similarly, x minus x naught is p plus n into h, here bracket here. But here we are considered in the equation, so this is x minus x1, not x minus x naught, it is x minus x1. Using these relations, the equation 2 reduces to y of x is equal to yn plus nabla yn. X minus xn can be written as p into h, the denominator we have h here, plus a2 can be written as nabla square yn by 2 factor into h square. X minus xn can be written as ph. X minus xn minus 1 can be written as p plus 1 into h plus and so on. So an, that is an can be written as nabla n yn by n factorial into h power n into x minus xn can be written as ph into p plus 1 into h and so on. X minus x1 can be written as p plus n minus 1 into h. I can write. So this implies y of x is equal to yn plus h get cancel p into nabla yn. Here h square get cancel p into p plus 1 by 2 factorial into nabla square yn plus p into p plus 1 into p plus 2 by 3 factorial into nabla cube yn plus and so on plus p into p plus 1 into and so on p plus n minus 1 by n factorial into nabla n yn. So this formula is known as Newton's backward interpolation formula to estimate the unknown values of y for given values of x. The Newton's backward interpolation formula is appropriate or suitable for finding the value of y at x, so that x must be near to the end value of the interval x naught to xn, so that x must be near to the xn, so then the Newton's backward interpolation formula is appropriate to estimate the value of y. So now we will move to the problems on Newton's backward interpolation formula. Take a first problem. The area of the circle of diameter d is given for the following values. Calculate the area of the circle when the diameter is 105. In the table we have the diameter, so 80, 85, 90, 95, 100. The corresponding the area 5026, 5674, 6362, 7088 and 7854. Here we need to find out the area when diameter is given, that is 105. The given diameter 105 is near to the end value of the interval 80 to 100, which is near to the end value of the diameter. So therefore Newton's backward interpolation formula is appropriate. We'll move to the solution. Let diameter can be taken as x and area of the circle can be taken as y. So therefore in the first row of the table consider as the x value and area can be taken as y. So now let us construct the difference table. The first column of the table we have x and second column of the table we have y values. So here x is 80, 85, 90, 95, 100. The corresponding the value of y 5026, 5674, 7 4 6 3 6 2 7 0 double 8 7 8 5 4. Let us construct the first backward difference here. 5674 minus 5026, that is 648. 6362 minus 5674, that is 688. 7088 minus 6362, nothing but 726. 7854 minus 7088 is 766. So let us move to Nabla square, second backward differences. 688 minus 648, that is 40. 726 minus 688 is 38. 766 minus 726 is 40. Nabla cube, third backward differences. 38 minus 40 is minus 2. 40 minus 38 is plus 2. So Nabla 4 is 4. 2 minus half minus plus 2, that is 4. So we have to find out y at x is equal to 105. So 105 is the diameter of the circle, and where y is the area of the circle. You have to find the area when diameter is 105. So the diameter 105 is near to the end value of the x value 100, where 105 is near to the 100. So therefore 7854 can be taken as yn. 766, 40, 2 and 4. So these are the leading backward differences. This is Nabla yn, Nabla square yn, Nabla cube yn, Nabla 4 yn. So you know that x is 105 is near to the 100, therefore you have to use Newton's backward interpolation formula. So we have y of x is equal to yn plus p into Nabla yn plus p into p plus 1 by 2 factorial into Nabla square yn plus p into p plus 1 into p plus 2 by 3 factorial into Nabla cube yn plus p into p plus 1 into p plus 2 into p plus 3 by 3 factorial 4 factorial into Nabla 4 yn. So this formula is known as Newton's backward interpolation formula. So here x is equal to 105 and xn is 100 and h is here 5. So we have x is equal to xn plus ph. So this implies p is equal to x minus xn by h, where x is 105 minus where xn is 100 by h is 5. This is equal to 5 by 5. This is equal to 1. Therefore p is equal to 1. So once if you know the p, let us substitute in the formula. Therefore y of 105 is equal to where yn is 7854 plus p is 1 into nabla yn is 766 plus p is 1 into p plus 1, that is 2 by 2 factorial into nabla square yn is 40 plus p is 1 here, p plus 1 nothing but 1 plus 1, that is 2 into p plus nothing but 3 by 3 factorial into nabla cube yn is 2 plus 1 into 2 into 3 into 4 by 4 factorial into nabla 4 yn is 4. After simplification we have y of 105 is equal to 7854 plus 766 plus 40 plus 2 plus 4. So this is equal to 8666. Therefore, the area of circle is 8666 when the diameter is 105. The second problem, find the first and 10th terms from the following table in which values of y are consecutive terms, of which 12.5 is the fifth term. So we have the data points in the table where x is equal to 3, 4, 5, 6, 7, 8, 9. The corresponding the y values are 2.7, 6.4, 12.5, 21.6, 34.3, 51.2, 72.9. Here fifth term is 12.5. So fifth term is 12.5 at x is equal to 5. So therefore fourth term is 6.4 at x is equal to 4. Third term is 2.7 at x is equal to 3. Similarly, second term y2 at x is equal to the first term yn at x is equal to 1. Means here we need to find out first term y at x is equal to 1, the first case. Similarly, we have to find out the 10th term. So this is fifth term 12.5, 21.6 is the sixth term, 34.3 is the seventh term, 51.2 is the eighth term, 72.9 is the ninth term. So you have to find out 10th term y at x is equal to 10. So y10 is the 10th term. We need to find out y1 at x is equal to 1 and y10 at x equal to 10. To find y at x equal to 1, we have to use Newton's forward interpolation formula, because x is equal to 1 is near to the beginning value of the x3. So to find y at x equal to 10, we use the Newton's backward interpolation formula, because x is equal to 10 is near to the end value of the x, that is 9. So therefore, to find y at x equal to 10, we use Newton's backward interpolation formula. To find y at x equal to 1, we use Newton's forward interpolation formula. But anyway, difference table is same for the backward or forward difference here. So let us construct the difference table for the given data points. In the first column of the table we have x, second column of the table we have that y values. So x is 3, 4, 5, 6, 7, 8, 9. The corresponding y values are 2.7, 6.4, 12.5, 21.6, 34.3, 51.2, 72.9. So let us construct the first differences, forward or backward differences here. 6.4 minus 2.7 is 3.7. 12.5 minus 6.4 is 6.1. 21.6 minus 12.5 is 9.1. 34.3 minus 21.6 is 12.7. 15.2 minus 34.3 is 16.9. 72.9 minus 15.2 is 21.7. So let us construct the second forward or backward differences. 6.1 minus 3.7 is 2.4. 9.1 minus 6.1 is 3.0. 12.7 minus 9.1 is 3.6. 16.9 minus 12.7 is 4.2. 21.7 minus 16.9 is 4.8. So let us move to the third forward or backward differences. 3.0 minus 2.4, 0.6. 3.6 minus 3.0, 0.6. 4.2 minus 3.6, 0.6. 4.8 minus 4.2, that is 0.6. Fourth forward or backward differences are 0. So for that in higher order differences also 0. Here to find the y at x equal to 1, where x naught is 3, therefore corresponding y naught is 2.7. So these are the leading forward differences. To find the value of y at x equal to 10, so therefore xn is 9, corresponding yn is 72.9, and the corresponding leading backward differences are 21.7, 4.8, 0.6 and zeros. So let us find out the y at x equal to 1 and y at x equal to 10 here. So first let us move to the finding y at x is equal to 1. Here we have x is equal to x naught plus ph. So this implies p is equal to x minus x naught by h. Here x is 1 minus 3, x naught is 3 here, and h is 4 minus 3, that is 1, that is equal to minus 2. So p is equal to minus 2. We use Newton's forward interpolation formula to find the value of y at x equal to 1. We have y of x is equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into plus delta square y naught plus p into p minus 1 into p minus 2 by 3 factorial into delta cube y naught plus further p into p minus plus and so on you can write here. So y at x equal to 1, that is y1, first term at x equal to 1 we have y naught is 2.7 plus p is minus 2 into delta y naught is 3.7 plus p is minus 2 minus 2 minus 1 minus 3 by 2 factorial into delta square y naught is 2.4 plus p is minus 2, p minus 1 is minus 3, p minus 2 is minus 4 by 3 factorial into delta cube y naught is 0.6. So this implies y1 or y at x equal to 1. This implies 2.7 minus 7.4 plus 7.2 minus 2.4. So this is equal to 0.1. The first term is 0.1. It means y at x equal to 1 is 0.1. So next you have to find out 10th term of the table. So to find 10th term of the table, you have to find y at x is equal to 10. So this value 10 is near to the end value of the given values of x. So therefore we use Newton's backward interpolation formula to estimate the value of y at x equal to 10. We have Newton's backward interpolation formula, that is y of x is equal to yn plus p into nabla yn plus p into p plus 1 by 2 factorial into nabla square yn plus p into p plus 1 into p plus 2 by 3 factorial into nabla cube yn and so on. So here x is equal to 10 and xn is 9 and h is 1. So this implies p is equal to x minus xn by h. So 10 minus 9 by 1, that is equal to 1. Therefore p is equal to 1. So p is equal to 1. So next we have the formula y of x is equal to, where yn is 72.9 plus p is 1 into nabla yn is 21.7 plus p is 1 and p plus 1 2 by 2 factorial into nabla square yn is 4.8 plus p is 1, p plus 1 is 2, p plus 2 is 3 by 3 factorial into nabla cube yn is 0.6. So this is equal to 72.9 plus 21.7 plus 4.2 2 to get cancel 4.8. So 2 into 3 6 and 3 factor get cancel plus 0.6. So this is equal to 100. Therefore y of 10 is equal to 100. It means 10th term is 100.